Now I'm just showing the answer here for the final part in question 1, paper 1, 2023. It is the unknown coefficients question, and so I'm just going to skip through the part A and B and go on to part C. Now I'm going to do this in a particular way, which is using it as rather than talking about long division, I'm going to use the multiplication method. So I say x squared minus px plus 1 is a factor of x cubed minus 2x minus 3r, where p and r are an element of the real numbers and p is less than 0. Find the value of p and the value of r. Now it's a long time since a question like this had come up, and so a lot of students did not like this last year. Now you can do the long division method, which is in the marking scheme, or you can set it up like this. You can say that if x squared minus px plus 1 is a factor, then it turns out that the other factor has to be x minus 3r. Now why is that? Because what we're saying, and again back to my kind of analogy that I often use, or my example, that like if 2 divides into 10, it divides in 5 times. 5 times 2 is 10. Line underneath changes signs, it cancels down to be 0. So I can say 2 is a factor of 10. I can say 5 is a factor of 10. But what I can say is 10 is a multiple of 2 times 5. Equally, for the same reason, I can say if x squared minus px plus 1 is a factor of x cubed minus 2x minus 3r, there's another factor of x cubed minus 2x minus 3r that when multiplied by this guy will give me the cubic. Okay? It must be a linear, because a linear times a quadratic will give me the cubic, and it turns out with a bit of thinking you realize that it has to be x minus 3r, and the reason is this: because if I have x squared and I need to multiply by something to get x cubed, well, that something must be x. It cannot be anything else. And if I have a constant 1 and I must multiply by something to get a constant minus 3r, well, it turns out that constant must be minus 3r. It cannot be anything else. So when I then multiply through these two brackets, well, what am I going to get? I'm going to get x cubed. So remember, like this, just multiplying through the bracket, like the x cubed times the x squared times the x is going to give me the x cubed. The x squared times the minus 3r is going to give me minus 3r x squared. The minus px times the x is going to give me minus px squared. The minus px times the minus 3r is going to give me plus 3rpx. Now it's sounding complicated, but we get there. The 1 multiplied by the x is the x, and the 1 multiplied by the minus 3r is the minus 3r. Okay? What happens next? Well, it's that famous word. We can kind of equate. Now, in this case, before we do that, what we can do is we can cancel down. Well, the x cubed, because we got an equation here, with the x cubed will cancel with the x cubed. The minus 2x's, well, we don't have anything to cancel with him at the moment, but we have a minus 3r that will cancel with the minus 3r. So now, where does this bring us to? Well, we're about to equate coefficients, so let me get rid of all my stuff here. So I can say I started off here with x cubed minus 2x minus 3r, but I could include a minus or a plus 0x squared. Okay, that's just to make the left hand side and the right hand side kind of look like each other. So I can say 0x squared must be equal to minus 3rx squared minus px squared. Otherwise, it just cannot work for all values of the variable. So therefore, if I have 0x squared equals minus 3rx squared minus px squared, well, it must be the case then that 0 is equal to minus 3r minus p. Similarly, I can say, well, I can equate my x's as well, but I'll simplify down first. I'm going to get p is equal to minus 3r. Okay? So then I'm going to say my minus 2x is equal to 3r px plus x. And again, so if I have minus 2x is equal to 3r px plus x, well, I can divide across everything by x, and I can say minus 2 is equal to 3rp plus 1. We know that p is equal to minus 3r, so I'm going to sub in then in a moment. I'm going to first just get my 3rp is equal to minus 3. I'm going to sub in once I get down to rp is equal to minus 1. So what I'm doing is, where I had p equals minus 3r, I'm subbing in for p here, so I get minus 3r squared equals minus 1. I can divide both sides by minus 3, so I get r squared is equal to 1/3. As I've said before, if you have the square root of 4, that's equal to plus 2. But if you got x squared equals 4, that means x is equal to plus or minus 2. And the reason is because this is a quadratic. For the same reason here, I get r is equal to, so I get r is equal to plus or minus the square root of 1/3. But the square root of 1/3 can be written as root 3/3. So I get plus or minus the square root of root 3/3. So what happens next? Well, in this case, right, we're going to keep an eye on something which is up on the top that says p has to be less than 0. And because p has to be less than 0, it's going to turn out that if p is equal to minus 3r over here, well, then r is going to have to be a positive to make p be a negative. So I sub in my root 3/3 for r, I simplify it down, I get p is equal to minus root 3, and that was my final answer for that. So r was equal to root 3/3 and p was equal to minus root 3. So look, not the easiest of questions. You could do it using long division as well, of course, but that was one way to do it using the multiples approach. Okay, I hope that makes sense. You'll also see it in the marking scheme.